Welcome everybody. In today's session, we will see short tricks on probability. Probability is also one of the important topics where you will get problems such as problems based on coins, problems based on dice, problems based on balls, and problems based on cards. Okay, so I have divided the problems in this chapter into 4 types. So each type we will see separate problems and how to solve them. So first we will see some introduction regarding probability. So what is probability? Probability is nothing but number of required outcomes divided by number of total outcomes. This is very important. Based on this we will solve all the problems. Okay, so what is probability? Probability is nothing but it is number of required outcomes, whatever is required, okay, that outcomes divided by the number of total outcomes. Okay, just remember this and all the problems will be based on this. So what are the different categories in which we can divide probability problems? That is coins based problems. In coins based problems we will have problems such as when a coin is tossed, when 2 coins are tossed, what is the probability of getting both heads, or what is the probability of getting both tails, isn't it? So problems like those are known as coins based problems. Okay, then we have dice based problems. Okay, dice, when we throw a dice, what is the probability of getting 6? Okay, or when 2 dices are thrown, what is the probability of getting multiple of 3 or sum of those both dices when they are thrown? Okay, what is the probability of getting the sum as 15? Like those problems. Okay, so those are dice based problems. Next we have balls based problems. What are balls based problems? Balls means different color balls will be there and they will be thrown in a box. Okay, so now for example, if there are black balls, some black balls, some red balls, some yellow balls in a box, what is the probability of getting 4 black balls and 3 red balls? Okay, so those type of problems we come across and those are known as balls based problems. And the 4th type are cards based problems. Okay, so what are cards? Cards are nothing but playing cards. Okay, what the cards what we play. Okay, so those cards based problems in which we will see problems such as when a card from a 52 pack of cards, when a card is drawn, what is the probability of getting a jack, what is the probability of getting a queen? Okay, like those. So those are categorized as cards based problems. So these are the 4 different types in which I have divided the problems, and for each type we will see different shortcuts. Okay, each type will have different shortcuts. But finally, to find the probability we use this formula itself. Okay, this formula only, but shortcuts will be different for each type. So let us begin with our first type, that is coins based problems. Okay, so before seeing the problem, one thing you should remember is, in a coin there are 2 faces, isn't it? In a coin there are 2 faces. That is, one face is head and the other face is tail. Okay, and one important formula to solve points based problems is the total number of outcomes. Okay, total number of outcomes or results, you can say total number of results or total number of outcomes, anything, is given by the phase raised to number of coins. Okay, phase raised to number of coins. So in a coin we know there are two faces, isn't it? So 2 raised to n, where n is nothing but number of coins. Okay, now for example, if they say 2 coins are tossed, 3 coins are tossed, so that is nothing but n, the number of coins used. Okay, and 2 is nothing but the face. A coin has 2 faces, isn't it? So 2 raised to n. So we'll see the first problem. Now first problems I will solve using logical method or the basic method. Then after solving using logical method or basic method, then I will tell you all the shortcut method. Okay, so first we will discuss all the problems using logical method or basic method. Now first problem, 2 coins are tossed simultaneously. Find the probability of getting head on both coins. Okay, they are saying 2 coins are tossed. What is the probability of getting head on both the coins, they are asking. What is the probability of getting? So this is our required outcome. Okay, so getting both head is our required outcome. This is required for us. Okay, required outcome. So I told you all, what is probability? It is required, total number of required outcomes divided by total outcomes. Okay, so required outcome is this for us, both should be head. But what are total outcomes? Okay, so we should know what are total, how many outcomes can be there when 2 coins are tossed. When 2 coins are tossed, we can either get head on both the coins, or tail on both the coins, or head and tail, or tail and head. Can we get any other probability, any outcome other than these? No. So total outcomes are how many? 4 outcomes. Okay, so totally we can get 4 outcomes. So this was using logical method. Okay, but using this formula also we can get total number of outcomes as same. So how using formula? So we know formula is nothing but 2 raised to n, that is 2 faces raised to n. So 2 raised to n is nothing but number of coins. So number of coins are how much they are saying? 2 coins are tossed, isn't it? So number of coins are 2. So 2 raised to 2 is 4. So total number of outcomes we got here also 4 and here also 4. Okay. So now we know that required outcome is what? Head. We require that both should be head. So how many outcomes are required? 1, isn't it? So probability is nothing but required outcome is 1 divided by total outcomes are how many? 4. So 1 by 4. Okay, so the probability is 1 by 4. Option A is the answer. We'll solve as we go on solving, you will understand. Okay, so we'll solve next problem. When 2 coins are tossed simultaneously, then find the probability of getting at least 1 head. Okay, 2 coins are tossed simultaneously. Okay, then we should get at least 1 head. Okay, so when 2 coins are tossed, what all possibilities we can get? We can get either head or tail, or 1 head 1 tail, or 1 tail 1 head. So these are the 4 possibilities what we can get. So what they are saying, at least 1 head should be there. At least 1 means this is also okay for us, this is also okay, and this is also okay. But here there are no head, so this we don't want this. Okay, so required outcomes are which all? Required outcomes we can get either head is also fine for us, because at least one should be head. It can be one or more than one, but not less than one. Okay, so one head one tail is fine, or one tail one head is fine, but this tail in this is not fine for us, because we want at least one head. So required outcomes are how many? 3. Okay, so total outcomes are how many from this? 4, isn't it? Total outcomes are, or we can say 2 raised to n, where 2 raised to number of points are how many? 2, isn't it? So 2 raised to 2 is 4. Okay, so therefore probability is nothing but required outcomes divided by total outcome. Okay, so required are 3 and total are 4. Okay, so therefore probability is what? 3 by 4. Okay, option D is the answer. Next problem. When 3 coins are tossed simultaneously, then find the probability of getting at least one head. Okay, in the previous problem 2 coins were tossed and they were asking at least one head. Now 3 coins are tossed and they are asking at least one head. Okay, so when 3 coins are tossed, what are the probable things we can get? We can get so when 3 coins are tossed, always write like this: 4 head, 4 tail. We will get 8 outcomes. Okay, 4 head, 4 tail. Then next line is 2 head, 2 tails. 2 head, 2 tails. And in the last row you can write 1 head, 1 tail, 1 head, 1 tail, 1 head, 1 tail, 1 head, 1 tail. So these are the outcomes, total outcomes. Okay, so total outcomes are how many? 8. Okay, these are 8. We can get it using formula also. So total outcomes is equal to 2 raised to n, whereas 2 raised to 3 coins are there, number of coins are 3. So 2 raised to 3, 2 raised to 3 is nothing but 8. Okay, so total outcomes, if we see like this also we are getting 8, like this also we are getting 8. Now required outcomes are how many? Required outcomes. So what is our required outcome? At least one head is our required outcome. Okay, at least one head. So 3 head is fine, 2 head is fine, here also 2 heads, here 1 head, because at least one is fine. Then 2 head is fine, 1 head and 1 head. But we don't want 3 tails, because at least 1 head we require. Okay, but 3 heads are but 3 tails are not required for us. So at least 1 head means these 7 conditions are satisfied. So therefore required outcomes is 7. Okay, so therefore probability is what? Required outcome divided by total outcomes. So required outcome is 7 divided by total outcome is 8. So probability is 7 by 8. Okay, option A is the answer. Okay, next problem. If 5 coins are tossed simultaneously, then find the probability of getting at least 2 heads. Okay, so to solve this kind of problem where 5 coins are used, solving like this in logical method it will be difficult. Okay, because 5 possibilities we have to go on writing. 5 possibilities means how many total outcomes we will get? 2 raised to 5, isn't it? 2 raised to 5 is nothing but 32. So 32 possible things like this writing is very difficult. So logical method only we will solve this. Okay, logic method. So in this, what are our required outcomes? They are saying at least 2 heads. Okay, so we can get either 2 heads in 5 coins. Okay, in 5 coins we can get either 2, because at least 2 we require, not less than 2, but it can be more than 2. So 2 heads, or we can get 3 heads, or 4 heads, or even 5 heads is fine. Okay, so more than this is not we cannot get, because only 5 coins are there. So 2 heads, but 1 head is not required, because they are asking at least 2. Okay, so 1 head is not necessary. So 2 heads or 3 heads or 4 heads or 5 heads. Now there are 5 coins. Getting 2 heads, we can use a combination formula here, NCR, that is 5 heads we can get, okay, sorry, 2 heads we can get from 5 coins in 5C2 ways. Okay, in 5C2 ways. Okay, similarly, OR means what? Plus. Okay, we have seen in permutation and combination, OR means plus, AND means into. Okay, now 3 heads. So 3 heads out of 5 we can get in 5C3 ways, plus 4 heads. 4 heads out of 5 we can get in 5C4 ways, plus 5 heads out of 5 coins we can get in 5C5 ways. Okay, now solve this. 5 into 4 divided by 2 plus 5C3 is nothing but it is equal to 5C2. It is nothing but equal to 5C2, isn't it? We have discussed it earlier, when 5C3 is equal to 5C2. How? The sum of R, okay, the sum of R, that is 3 plus 2, should be equal to the n value. Okay, we know n value is 5 here, isn't it? 5 both the sides. So when we add these R values, it should be equal to n value. Okay, R, when we add, it should be equal to n value. So 3 plus 2 is equal to 5. So 5C3 is equal to 5C2. So this I can write it as 5 into 4 divided by 2 plus 5C4, it is equal to 5C1, it is equal to 5C1, isn't it? And 5C1 is equal to 5 plus 5C5 is equal to 1. So 2 1s are 2 2s are 2 1s are 2 2s are. So it is 5 2s are 10 plus 5 2s are 10 plus 5 plus 1. So it is 26. Okay, so required outcomes are 26, and this is our total outcomes. Total outcomes are how many? 32. So therefore probability is equal to required outcomes divided by total. So required are 26 divided by total are 32. Okay, so probability is nothing but, we got it as 26 divided by 32. Option D is the answer. Now we saw these problems how to solve using basic method or logic method. Now we will discuss the short trick. Okay, how to use short trick to solve coins based problems. Okay, so I will explain it here. Okay, solving coins based problems using short trick. Okay, using short tricks. So I will give you one table, okay, and that table is very important. Okay, if you by heart that table, and it is very easy to by heart also, if you by heart that table, you can solve any coins based problems. Either it can be 5 coins, 7 coins, 8 coins, any number of coins. Okay, you can solve those type problems in hardly 1 or 2 seconds. Okay, so what is the table? When 1 coin is tossed, when 2 coins are tossed, when 3 coins, 4 coins and 5 coins. Okay, so when 1 coin is tossed, remember this. When 2 coins are tossed, 2 1. When 3 coins are tossed, 3 3 1. When 4 coins are tossed, it is 4 6 4 1. And when 5 coins are tossed, it is 5 10 10 5 1. If you remember this table, and it is very easy to remember, just remember 1 coin is tossed, it starts with 1. When 2 coins are tossed, it starts with 2 and 2 1. 3 coins are tossed, it is 3 3 1. 4 coins are tossed, 4 6 4 1. 5 coins are tossed, 5 10 10 5 1. If you remember this simple table, you can solve any number of coins problems. Okay, and this column indicates 1 head 1 tail. Okay, So this is 2 head 2 tails for, and this is for 3 heads 3 tails. This is 4 heads 4 tails, and this is 5 heads 5 tails. Okay, just remember this much and any problems you can solve. Okay, so how is that? We will see one by one. Those previous problems only what we solved, those only we will solve again using this table. Okay, so what was the first problem? 2 coins are tossed simultaneously. Find the probability of getting head on both coins. Okay, so 2 coins are tossed and we should get head on both the coins. Now see the table. So first problem is 2 coins are tossed. Okay, and we should get head on both the coins. This was the problem. Now 2 coins are tossed means we should see this row. Okay, 2 coins are tossed means we should see this row. Now they are asking both should be head, isn't it? Both should be head, they are saying. So both head means 2 heads we want. So this column and this row, okay, this column we should see and this row. Okay, 2 coins and 2 heads. So we should remember when 2 coins means the probable outcomes are 2 and 1, and this first column will be for 1 head 1 tail, 1 head or 1 tail, and second will be for 2 head and 2 tail. Okay, so we know that 2 heads we want, so the required outcome will be 1. Okay, so what we know, probability is nothing but required outcome by total. So required outcome, how much we got? 1. 1 divided by total outcomes is, we know that 2 raised to the number of coins. Number of coins is 2. So it is 1 by 4. Okay, same answer we got, 1 by 4. See here, same answer we got, 1 by 4. Instead of doing all these steps, okay, we just got the answer in just single step. With only in this single step. Okay, so let us see the next problem. See here, when 2 coins are tossed simultaneously, then find the probability of getting at least 1 head, they are saying. Okay, 2 coins and 1 head. So when 2 coins is there, what is the outcome? Probable 2 and 1, we know that, isn't it? And first column is for 1 head 1 tail, and second is one for 2 head 2 tails. So they are saying at least 1 head. At least 1 means both also can be head, isn't it? So probable outcome is for us, required outcome is 1. So probability is nothing but 1, and 2 raised to, we know 2 coins, isn't it? 2 coins means 2 raised to 2. So it is 1 by 4. Sorry, at least 1 head. Okay, so 1 head is also fine for us, 2 head is also fine. So 2 plus 1, how many outcomes, required outcomes we can get? We can get 2 plus 1, 3. Okay, so that is 3 divided by 4. Okay, 1 head is also fine, 2 head also. Sorry, I made a mistake. So 1 head is also fine, 2 head also is fine, because at least 1 head they are saying. So 2 plus 1, 3 required outcomes we can get. So probability is required divided by total. So required is 3 and total is 2 raised to 2 coins means 2. So 3 raised to 4, 3 by 4. Okay, so just compare here. Instead of doing all these things, we can get it in just one step. Okay, next, when 3 coins are tossed simultaneously, then find the probability of getting at least 1 head. Okay, so when 3 coins, what is the table you should remember? It is 3 3 1. Okay, see here, it is 3 3 1. Remember this much and you will be able to solve any number of problems. Any number of coins they give, you will be able to solve. Okay, so when 3 coins are tossed, it is 3 3 1. Now they are saying at least 1 head. So first column was for 1 head, second was for 2 heads, and third one was for 3 heads. So at least 1 head means this is also okay for us, this is also okay, and this is also okay. So it is 3 plus 3 6 plus 1 is 7. So 7, all these 3 are okay for us, therefore required outcomes are 7. Therefore probability is required divided by total. So required is 7 divided by total is 2 raised to, how many coins are there? 3. So 2 raised to 3. So that is, which is equal to 7 divided by 8. Okay. So in just one step we got the answer. Okay. Next problem. Now if 5 coins are tossed simultaneously, then find the probability of getting at least 2 heads, they are saying. Okay. So when 5 coins are tossed, so when 5 coins are tossed, what is the table for us? It is 5, 10, 10, 5, 1. So this is the table, isn't it? See here, 5, 10, 10, 5, 1. Okay. This is for 1 head, this is for 2 head, this is for 3 heads, this is for 4 head, and this is for 5 head, isn't it? Now what they are saying, at least 2 heads we want. Okay, at least 2 heads. At least 2 heads means 1 head is not okay for us. 2 heads okay, 3 heads okay, 4 heads okay, 5 heads okay. So these are okay, but this is not fine. So totally how many are okay for us? 10 plus 10, 20, plus 5, 25, plus 1, 26. Okay. So required outcomes are 26. Therefore probability is required divided by total, which is equal to, required is 26 divided by 2. Total is 2 raised to n. 2 raised to n is 5 coins they had told, isn't it? So 2 raised to 5. So it is 26 divided by 2 raised to 5 is 32. Okay. So probability is 26 divided by 32. See here how so easily in one step we solved the problem. See here, instead of doing all these things here, we could solve the problem in just one single step if you remember this table. Okay. See here, if you just remember this one single table, you will got the answer in just few seconds. Okay.